Welcome student. Last video I discussing the introduction part of potentiometric titration. In this point we see that when are used a potentiometric titration, and another one part is the how to calculate the cell potential of any electrode by using Nernst equation. These main points are discussed about in last video. Now in this video next point is determination of pH. Determination of pH. Then how to determine the pH of the any solution? How to determine the pH of the any solution? What is the pH? pH is equal to negative logarithm of H plus ion concentration. pH is the negative logarithm of H plus ion concentration. You already know that. Then EMF of any cell. EMF means cell potential or reduction potential. EMF of any cell depends on H plus ion concentration present in the solution or pH of the solution. The EMF of half cell. How to determine? Suppose calculate the EMF of half cell. This half cell is coupled with another half cell. एखाद्या हाफ सेलचं EMF कॅल्क्युलेट करण्यासाठी this half cell is coupled with another half cell, and to form the complete cell, then calculate the EMF of this complete cell. For example, to calculate the EMF of hydrogen electron. Then which process are take place? The hydrogen electrode is, suppose hydrogen electrode is dipped in the solution of H plus ion concentration. This is the hydrogen electrode, and this hydrogen electrode dipped in the H plus ion concentration. This is the one half cell. This hydrogen electrode dipped in the concentration of H plus ion. In this cell, which reaction are carried out? For example, in this solution are H plus ions is there. This H plus ions means this near the one electron. Then gives one half H2. Means this H plus ions are gain the electron to form the one half H2. This is the reduction. Because gain of electron. Then this reaction use the Nernst equation. In this reaction applied the Nernst equation. What are the Nernst equation of in this reaction? EH2 means hydrogen electrode. EMF of hydrogen electrode is equal to E0H2 plus 2.303 RT upon NF log of concentration of H plus ions. E means EMF of hydrogen electrode, and this E0H2 means standard cell potential of hydrogen electrode. This is the cell potential of hydrogen electrode, and this E0H2 means standard cell potential of hydrogen electrode. This log means concentration of H plus ions, means this solution present in the H plus ions. In this standard cell potential of hydrogen electrode is always zero. The standard hydrogen potential of value is always 0. Then what is the equation? Equation is equal to EH2. This is the value is 0. because standard cell potential of hydrogen electrode is always 0. Then EH2 is equal to 2.303 RT upon NF log of concentration of H plus ions. Concentration of H plus ions. Then N is the number of electron take part in the oxidation or reaction. In this reaction, only one electron are take part. That's why N is equal to 1. Then 2.303 RT upon F. N is the number of electron take part in the means N is equal to 1. Then log of concentration of H plus ions. Then log of concentration of H plus ions. This is the EH2. Then this constant value is evaluated to form the minus 0.0591 pH. Minus means this value is calculated to gives the this value. That's why minus 0.0591 pH. This is the cell potential of hydrogen electrode. This is the cell potential of hydrogen electrode. Means this pH means already told that pH is the negative logarithm of H plus ion. That's why this concentration of H plus ions put the value pH. Put the value pH. This EMF of H2, this EMF of hydrogen electrode depends on the pH of the solution. Depends on pH of the solution. Means EMF of this hydrogen electrode depends on the pH of the solution. Then how to calculate the pH of this hydrogen electrode? Calculate the pH of any solution by using hydrogen electrode. That's why this hydrogen electrode is coupled with, suppose to calculate the EMF of hydrogen electrode, that's why this hydrogen electrode coupled with another electrode. This hydrogen electrode coupled with another electrode. See here diagram. This hydrogen electrode coupled with another half cell. This is the hydrogen electrode. This is the hydrogen electrode. This hydrogen electrode coupled with another half cell or another electrode. Another electrode. This another electrode is also called as a reference electrode. Reference electrode. In this cell, reference electrode used a saturated calomel electrode. Means this is the saturated calomel electrode. Means this is saturated calomel electrode is the reference electrode. That's why this hydrogen electrode coupled with another half cell or another electrode, that electrode is called as a reference electrode, and this reference electrode is also called as saturated calomel electrode to form the complete cell. Then calculate the EMF of this hydrogen electrode. This is the complete cell, and then this complete cell to use to determine the EMF of hydrogen electrode. EMF of hydrogen electrode. This is the diagram. Then how to representation of this cell? How to represent of this cell? See here, platinum electrode. This is the platinum H2 hydrogen electrode. Gas 1 atmosphere. G means gas. Then this H plus ions. H plus ions concentration. And double slash, this is the saturated calomel electrode. This is the diagrammatically, this is the representation of this cell. This is the platinum electrode. H2 means this hydrogen electrode in present of gas, and this solution is the H plus ions concentration, and double slash and another electrode is saturated calomel electrode. This double slash is also called as used by salt bridge. Used a salt bridge. This double slash means, this meaning of this double slash means salt bridge. Means this is the hydrogen gas electrode, this is the H plus ion concentration, and this another is the saturated calomel electrode. Saturated calomel electrode. Then how to calculate the EMF of hydrogen electrode? See here, E is equal to ER minus EL. EMF of the cell is equal to ER minus EL. ER means EMF of right side and EL means EMF of left side. What is the EMF of right side? In right side, which cell is there? Saturated calomel electrode. That's why EMF of saturated calomel electrode minus EMF of hydrogen electrode. In this cell, which is the right side is? Right side cell is saturated calomel electrode and left side is hydrogen electrode. That's why EMF of the cell is ER minus EL. ER means E right side is saturated calomel electrode minus E left means such hydrogen electrode. Then the value of saturated EMF of saturated calomel electrode is the value of or EMF of saturated calomel electrode is always constant. This value is 0.2422. The value of saturated calomel electrode is 0.2422. Put the value this equation 0.2422 minus 0.2422, and what is the value of EMF of H2 gas? You already calculate here, already calculated. This is the EH2 is equal to minus 0.0591 pH. This value is put up in this equation, means minus into bracket minus 0.0591 pH. 0.0591 pH. This is the E cell of this complete cell. This is the EMF of this complete cell. EMF of this complete cell. Then what is the equation? 0.02422 minus minus plus. That's why 0.0591 pH. 0.0591 pH. This is the EMF of this complete cell. This is the EMF of this complete cell. But you need the pH. How to determine the pH of the solution? That's why E minus this plus is the transfer in this. That's why minus 0.2422 is equal to 0.0591 pH. 0.0591 pH. You need to calculate the pH. That's why pH is equal to E minus 0.2422 divided by 0.0591 divided by 0.0591. This equation is used to determine the pH of the any solution by using hydrogen electrode. This equation is used to determine pH of the solution by using which electrode are used? By used hydrogen electrode. That's why to calculate the pH of the any solution by using hydrogen electrode, this equation is used to determine the pH of the solution. This is the important equation for the determination pH of the any solution.